Okay, so now we're gonna start with an easy example. Let's say like we wanna append two linked lists. So now we have two separate linked lists, one with the H1 head pointer, one with the H2 head pointer. Let's say like we wanna append this linked list at the end of the other one, okay? So similar to what we did before, we're gonna have a pointer, let's call it P, and we write a code while P arrow next is not, so first of all initialize P with H. I'm gonna intentionally make a mistake and then ask you guys to correct it for me. P equal to H while P arrow next is not equal to null. What should I do to traverse through the linked list? P is equal to P arrow next. So what happens here, it means that this P, it's gonna move to this one, this one, this one, and eventually comes here. It basically points to, the P itself doesn't move, like it means that it points to this one, okay? I could have like left this one here and just like draw a longer arrow, but so that's what's happening here. Now, after the loop, what do we need to do? We just need to say, we want this pointer, instead of being null, we want it to be pointing to this node. So we want P arrow next to be equal to H2. That was a very easy example. There is one problem here. There's one problem here. What if one of these two linked lists is already empty? What if like H1, like this was H1, sorry. What if H1 is already null? Then this doesn't exist. So this is gonna give me an error, right? So to make our program complete, we would be basically better to have this one. If H1 is equal to null, then basically you just like need to, okay, in this case, when we are done, we want to return the H1, right? It's gonna be the head of the new appended linked list. If H1 is equal to null, means that like, okay, there's nothing to be added from this linked list to here, so just return H2. And the same thing here, if H2 is equal null, there's nothing here to be added that, so return H1. There's no need to traverse. Okay, so just wanted to remind you that you have to consider if our linked list is empty, if it only has one node, only has two nodes. So different cases, you have to make sure that your code works for every scenario. The next example I want to show you, we did inserting a node in the linked list. We want to see how to delete a node, how to remove a node from a linked list. Okay, so let's do a linked list again. I'll just write null here. And let's say this is our head pointer, pointing here. Okay. What if I just want to delete the first node? Okay, so first, I'm just gonna do this. I'm gonna initialize another pointer, say node star. T is equal to H. Okay. If I want to delete the first node, let's say if n is equal to 1, means that if n is the node that we want to delete. If we want to delete the first node, then what do we have to do here? Then we want H to be pointing to this one. Do we have a pointer that points to that one? Yes, we do. It's here. So we can say H is equal to, actually I can say either H arrow next or T arrow next, doesn't matter. Okay. Again, if this is an empty list, you have to check it. If it's empty, there's nothing to delete. But we assume that it's not empty list, right? So if that's the case, H is equal to H arrow next, right? So this means that H is now gonna point to here. Okay, are we done? We're done with the linked list, but there's one problem. We wanted to delete this one. If we don't delete it, we have memory leak, right? So we have a pointer pointing to it, so we just say delete T. Okay, so that was easy. If you wanted to delete the first element, that was very easy. Okay. Now, let's say that we want to delete the nth element. This is the nth element and we want to delete it. Okay, so I have a pointer, let's call it current C, that I initialize it with H, and I move it all the way to here. I move it all the way to here. Okay. So in this case, this is the node that I want to delete. Okay. So it means that I want this to point here. Okay. Actually, it's possible for me to say C arrow next is equal to C arrow next arrow next. If that's the case, this is gonna happen. This is gonna move here. This is gonna be gone. What's the big problem here? Our linked list is okay. Our linked list works fine. But we have memory leak. We wanted to delete this one. Now I don't have any pointer pointing to this one to delete. Okay? So in many cases, in order to avoid such a problem, instead of just one pointer to traverse through the linked list, we might need to have more pointers. So what I do here, I have two pointers. I'm just gonna say that C is equal to H, and I'm gonna write while, let's say like we have like n minus 2 iterations to end up here. So while we traverse through this linked list n minus 2 times, and I'm gonna say that